Stable Diffusion is a deep learning text-to-image diffusion model which can generate photorealistic images given any text input. Diffusion models are generative models, which means they generate data similar to the data on which they're trained. During the training of the model, they actually destroy the training data by adding Gaussian noise until it diffuses into random noise, and then it teaches itself how to recover the data by reversing the process. After it's trained, a diffusion model then generates an output by passing randomly sampled noise through the learned denoising process. This model was trained on a huge data set of paired images and captions, and what you're seeing here in the GUI is the inferencing side of the Stable Diffusion model. As you can imagine, training a model like this from scratch takes a lot of compute horsepower in the form of AI accelerators. We've already got a text input typed in, so let's generate an image. We have this demo running on 2-socket 4th Gen Intel Xeon Scalable processor-based platforms, and is creating this unique image from our text input in about 5 seconds. Now let's break down the training and inferencing portions of the model into a little more detail. On the training side, the good news is that you don't necessarily need a bunch of AI accelerators to train your neural network from scratch. What we've done here is what's called fine-tuning, which leverages the pre-trained model and trains the last couple of layers with a smaller custom data set. We started with a single 2-socket 4th Gen Xeon node using stock PyTorch at FP32 precision, and we were able to fine-tune it in about an hour and a half. If we scale it out to 4 nodes and use our Intel extensions for PyTorch or IPEX at bfloat16 precision, where we can take advantage of Intel AMX, we were able to reduce that time to train to just under 5 minutes. Most companies aren't training from scratch, so this means you don't necessarily have to add accelerators to tweak a model for your business. Start with the Xeons you have that are already running your business and see if it meets your training needs. Now let's look at the inferencing side. Similar situation here. We start with a single 2-socket node running stock PyTorch, and it's able to infer an image in about 13.5 seconds. Add IPEX optimizations, and again using bfloat16 precision to take advantage of Intel AMX, and we're able to get a speed up of about 2.7x. That's what you were seeing in the GUI, where the image was inferred in about 5 seconds. Any of these AI models could potentially take advantage of an accelerator, but there's a reason that Intel Xeon Scalable processors represent approximately 70% of the processor units that are running AI inferencing in the data center. They can run any AI workload, and the Intel AI software portfolio enables out-of-the-box performance and end-to-end productivity.